Assalamu alaikum, my dear student. How are you? Hope you are well. This is Muhammad Ashraful Islam, lecturer, Department of Physics, Milestone College. Today I am here taking our online class. I hope this class will help you the better study at your home. Okay, let's start our today's class. Today I am going to discuss chapter 5. The topic of the chapter 5 is pressure and states of matter. And today I am going to solve two creative questions. First creative question from Mymensingh Board 2020. Look at the stem. In the stem you can see a figure where two cylinder C1 and C2 are given, and in first piston the radius is here 3 cm and the second piston radius is 6 cm, and 1000 Newton force is applied on the first piston and the position of the first piston was M, and after applying 1000 Newton force on the first piston, the position of the first piston will be N. That means the piston displaced 6 cm, and due to the displacement of the piston, the water will give the pressure in the large piston or second piston, and for that reason the piston will rise up 1 cm from its position S to T. This is the stem. And look at the question number 1. The question A is, what is called pressure? This is very easy definition and the very important definition of the chapter. Pressure means the force exerted perpendicularly to a unit area of a body. It's called pressure. The unit of pressure is Pascal or Newton per meter square, and dimension of the pressure is M, L inverse 1, T inverse 2. Now question number B. The question says, why the unit of stress and Young's modulus are same? You know, stress is the amount of force exerted in a unit area of a body is called stress, and you know stress equals to force divided by area, and unit of stress is Newton, area is meter square, so unit will be Newton per meter square. Similarly, we know the Young's modulus is the ratio of stress and strain, and Young's modulus it is denoted by Y, and the formula is stress divided by strain, as the strain is the ratio of the same quantity, so there is no unit of strain. So the unit of Y or Young's modulus only depends on the stress. So the unit of Young's modulus is equals to the unit of stress. Now we can write stress equals to force by area, and strain is del L divided by L naught. Here del L is the increasing length and L naught is the initial length. As the unit of length is equal, so we don't get any unit from the strain. We only get the unit of force is Newton, unit of area is meter square. So this is the unit of Young's modulus, and you can see the unit of Young's modulus and stress are same. Hope you have understand. Now let's see the question number C. The question is, find the experienced force on the piston of cylinder C2. That means we have to calculate the experienced force or F2 in the second piston C2. So let's see what is the given quantity here. Here radius of the first piston is given. Radius of the first piston is given. Radius of first piston is R1 and which value given here 3 centimeter, and we have to convert centimeter unit to meter unit. So we have to divide by 100, then we will get answer 0.03 meter, and the radius of the second piston, radius of second piston R2, and which value is given here 6 centimeter, and you have to convert centimeter unit to meter unit. We have to divide by 100 and answer will be 0.06 meter. Here you can see a force is given. This is the force acting on the first piston. So we can write here force on first piston. The force on the first piston is F1 and which value is given 1000 Newton, and we have to calculate the experience force for the second piston. So we can write here force on second piston. Value of force in second piston or experience force is F2, and we have to calculate the value of F2. So we can write here F2 equals to what? Now our formula is, we know F2 by F1 equals to R2 square divided by R1 square. Now we have to put the value of F2. So we have to change the position from F1 from left side to the right side. So we can write F2 equals to, value of R2 is 0.06 square and value of R1 is 0.03 square, and value of F1 will be multiplied with that expression, and the value of F1 is 1000, and after calculation that expression we will get F2 equals to 4000 Newton. This is the answer of question number C. Hope you have understand. Now question number D. The question is, energy is not increased in the event of the stem. That means we have to calculate the energy or work done for both piston, for first piston and for the second piston. Here you can see 1000 Newton force is applied in the first piston and the piston displaced 6 centimeter. So we can easily calculate the work done by the first piston. Again, here the existing force of the second piston is F2 and the piston displaced here 1 centimeter. So we can calculate the work done of the second piston. Now in case of first piston, here force F1 and F1 is given 1000 Newton, and the displacement of the first piston is this is S1 and the displacement is here 6 centimeter, and 6 centimeter equals to 0.06 meter, and we have to calculate the work done. Work done is W1. We consider for first piston work done is W1, and we have to calculate the value of W1. So W1 equals to what? And we know the formula to calculate the work done. We know the formula to calculate the work done is W1 equals to F1 into S1. Here F1 and S1 is given. We can write W1 equals to F1 is 1000, S1 is 0.06, and after calculation that expression we will get W1 equals to, that means work done by the first piston is 60 joule. Now we have to calculate the work done in the second piston. We can write, in case of second or C2 piston, the given quantity here force is F2. This is experienced from the first piston, and we have already calculated the value is 4000 Newton, and we got it from C. Got the value from C. So we can write here from C, and the piston displaced 1 centimeter. So we can write here displacement S2 equals to 1 centimeter. 1 centimeter equals to 0.01 meter, and work done by the second piston. Work done by the second piston is here W2. W2 equals to what? The same formula. The formula of work done is W2 equals to F2 into S2. Now if you put the value of W2 and S2, then we can write W2 equals to F2 is 4000 and S1 is 0.01, and after calculation that expression we will get the work done by the second piston is 40 joule. Now let's see the work done for both piston. W1 is 60 joule and W2 is 40 joule. So we can say the work done or the energy is increased. The energy or work done is not same. So our conclusion is W1 not equals to W2. The work done is or energy will be increased. Now creative question number 2. Question from Dhaka Board 2020. Let's see the creative question. The creative question is length, width and height of a brick is 25 centimeter, 12 centimeter and 6 centimeter respectively. The mass of the brick is given 2.25 kg. The density of the water is 1000 kg meter per cube, and g, that means acceleration due to gravity, is 9.8 meter per second square. This is the stem. Now question A is write down the Hooke's law. Hooke's law states that in an elastic limit, stress is proportional to the strain. That means we can write stress is proportional to strain within elastic limit. Next question, question number B. The question says why the density of water below and upper portion of the pond is different during the hot sun? Because the temperature. You know, the density of any material depends on the temperature, and in the surface of the pond the temperature is more than the bottom of the pond. As the temperature in the surface of the pond is more, so the density of the water at the upper surface of the pond is more compared to the lower surface of the pond. That is why density is different upper surface and lower surface. I hope you have understand. The next question, question C is determine how much maximum pressure acts on the surface by the brick. Here you can see the brick has length, breadth and height. And you know, if you want to maximum pressure, then area must be less. Let observe the question first. We know pressure is inversely proportional to area. That means if area is less, then the pressure will be more. So if you want to calculate the maximum pressure, then the area must be taken minimum. If we choose the width and the height, then you will get the minimum area, and by the minimum area you will experience the maximum pressure. So let's solve the math. First, we have to write the given information. Given information here, length. Length is given. Length is given here 25 centimeter, and if you convert centimeter to meter, we have to divide by 100 and the result will be 0.25 meter. And width of the brick, width, it is denoted by capital letter B, which is given 12 centimeter. And if you want to calculate centimeter unit to the meter unit, so we have to divide by 100 and answer will be 0.12 meter. Similarly, height is also given. Height is also given here 6 centimeter, and 6 centimeter equals to 0.06 meter. Now we can calculate the area. Area A equals to, we have to take breadth and height as we are going to calculate the maximum pressure, because the multiplication of breadth and height will be minimum compared to the another two dimensions. So if you put the value of B, that is breadth 0.12 and height 0.06, then we will get area equals to 7.2 into 10 to the power minus 3 meter square. Now we have to know what is the force. Here force is not given, but mass is given. Here mass is given, mass small letter m, which is given 2.25 kg, and we can calculate the weight by using the formula of weight is, so we can write weight W equals to mg. Here mass is 2.25 and g is here 9.8, and after calculation that expression we will get the weight of the brick is 22.05 Newton. The formula to calculate the pressure is, we know formula of pressure P equals to F by A. Now I am going to put the value of F and A. The value of F is 22.05 and area is 7.2 into 10 to the power minus 3. We will get pressure P equals to 3062.5. Let's see the creative question number. Let's see the question number D. The question says whether it is sink or float when pieces of same size wood of density 400 kg meter per cube placed in pair with the brick, then put them into the water. So we have to calculate the density of the brick with the wood. If the density of the brick with wood is less than the density of water, then it will sink. And if the density of brick with wood is more than the density of water, then it will sink. So let's solve the question D. First, I will write the given information. Length is given here. Length L is given here 25 centimeter, and 25 centimeter equals to 0.25 meter. Breadth or width is given. Width B is given here 12 centimeter, and it will be 0.12 meter. Height of the brick is given here 6 centimeter. You can see height is given here 6 centimeter, and 6 centimeter equals to how many meter? 0.06 meter. Now we have to calculate the volume. So we can write here volume of brick V1, and we can write here length multiply breadth and multiply height. If we multiply the length, width or breadth and height, then we will get the volume. Now if we put the value of length, which is 0.25, breadth is 0.12 and height is 0.06, then after calculation that expression, we will get the answer is 1.8 into 10 to the power minus 3 meter cube. But in the question they said the volume of the wood will be equal to the volume of the brick. So we can write the volume of the wood, volume of wood. Suppose this volume is V2 and V2 will be same to the V1. So we can write here V2 equals to V1, and that is 1.8 into 10 to the power minus 3 meter cube. Now we have to calculate the mass of the wood, because mass of the wood is not given, but density of the wood is given here. So we can write here density of wood. Suppose this is rho 2 and rho 2 is given here 400 and unit is kg meter per cube. Now we can calculate easily the mass of the wood. So our formula will be, we know rho equals to m by v. As we are going to calculate the mass of the wood, so density of wood is rho 2, mass m2 and volume v2. Now we have to calculate the mass, so we can write m2 equals to rho 2 into v2. Rho 2 is the density of the wood, which is given here 400 kg. V2 is the volume of wood, which is similar size to the volume of the brick. So we can write here V2 equals to 1.8 into 10 to the power minus 3. Now if you put the value of rho, which is 400, and V2 is 1.8 into 10 to the power minus 3, then we will get the mass of the wood M2 will be 0.72 kg. This is the mass of the wood. Now if we want to calculate the density of the brick with wood, so we have to add the mass. That means we have to need the total mass and total volume. Then we can calculate easily the density of the wood with the. Now we can write here total mass of brick and wood, that is M equals to M1 plus M2, and value of M1 is given 2.25 and M2 is 0.75. M equals to 2.97 kg, and the total volume of the brick and wood. Now we can write here again total volume of brick with wood is V1 and V2, and V1 and V2 will be equal, so we can write here 2V1, that is 2 into 1.8 into 10 to the power minus 3, and the volume will be V equals to 3.6 into 10 to the power minus 3. Now the main formula of that math is density rho equals to m by v. Here mass is 2.97 and volume is 3.6 into 10 to the power minus 3. And after calculation that expression, we will get density equals to 825, and unit will be kg meter per cube. And as you know, the density of water is 1000. As you know, density of water, rho W is 1000 kg meter per cube. That's all, and that value already given in the stem. Now if we compare the density of the brick with the wood and the density of water, then you can see the density of water is more than the density of the brick with wood. That is why we can say rho W is greater than rho. So our decision is The brick with floats float on water. That's all for today. My dear student, practice that two creative questions that I have discussed in that video class and submit your subject teacher as homework. Thank you for being with me.